Behind every single online purchase, every time you save a file, there's this really powerful concept working in the background to prevent total digital chaos. It's like an invisible safety net that keeps everything reliable, especially when your connection flakes out. It's called idempotency, and once you get it, you'll understand a core secret of how the modern web actually works.
So to really get why this matters so much, let's start with a problem that I am pretty sure is familiar to, well, almost everyone, the double charge nightmare.
Okay, picture this. You're there, you're ready to buy something online. You put in all your details, you take a little breath, and you hit that pay button. And then nothing. Just that spinning wheel of doom. The page is frozen. What do you even do in that moment? Your first instinct, right, is to just refresh the page and try again. But as you go to click that button a second time, this little wave of panic starts to set in. You start thinking, wait, did the first click go through? Am I about to get charged twice for the same thing? This is the exact moment where that invisible safety net we're talking about really needs to kick in.
And that safety net, it has a name. Idempotency. It sounds kind of technical, but it's really just this elegant engineering principle that makes sure things stay stable and reliable when, not if, but when, things like your internet connection inevitably go wrong.
So what is it exactly? Well, an operation is idempotent if doing it over and over and over again gives you the exact same result as just doing it once. It doesn't matter if your request gets sent 1 time or 10 times, the final outcome is not going to change after that first successful try. To make this crystal clear, think about a super simple math function, absolute value. The absolute value of -5 is 5. Now, if you apply that same function again to the result, which is 5, it's still 5. No matter how many times you repeat the operation, the outcome is totally fixed after that first try. That's idempotency in its purest form. Okay, now let's bring this into the world of programming. Imagine an instruction to set a user's status to active. That's idempotent. You can run that command 100 times, and their status just stays active. But an instruction to add 1 to their login count, that is not idempotent. Every single time you run that command, the state changes. The number just keeps going up and up. All right, so if some operations aren't naturally idempotent, how do systems make them safe to repeat? I mean, how do they actually remember if they've already processed your payment request? The answer is this really clever trick called an idempotency key. You can think of it like a unique tracking number or a passport for every critical action you take. When you click pay, your request isn't just sent out into the void. It's sent with this special one-of-a-kind key. So here's how it all flows. Your app creates and sticks that unique key onto your request. The server gets it and immediately checks its records, basically asking itself, hey, have I seen this key before? If it's brand new, great. The server processes your payment and then saves that key to its list. But if you hit refresh and send the exact same request with the exact same key, the server recognizes it and says, whoa, hold on, I've already done this one. It totally ignores the new payment request, but still sends back a success message. Your screen unfreezes, and you can breathe a sigh of relief knowing you weren't double charged. Now, this whole idea isn't just for payments. It's actually a fundamental part of how the web itself is designed to be reliable. It's built right into the protocols that power our daily browsing. Just take a look at the standard HTTP methods. These are like the verbs of the internet. A GET request, which just fetches data, is naturally idempotent. So is PUT, which updates something to a specific state, and DELETE, which, well, deletes it. The big exception here is POST, which is used to create something new. Hitting POST twice usually means creating 2 new things, which is exactly why it often needs those special idempotency keys we just talked about. And the logic for why DELETE is idempotent is it's beautifully simple. Once something is gone, it's gone. Trying to delete it a second time, or a third, or a 10th time has no further effect. The resource is already removed, so the final state doesn't change. Now, as powerful as this all is, actually implementing idempotency isn't always a walk in the park. It comes with its own set of trade-offs, and it really requires some careful planning. For instance, every single time a server has to check a key, it adds a tiny bit of delay. And you have to store all those keys somewhere, which takes up space. In big distributed systems, this gets really complicated. You have to make sure all these different servers, all these different brains, agree on which keys they've already seen. And then there's the time window. How long do you remember a key? If it's too short, a user might get double charged an hour later. If it's too long, you end up storing mountains of useless data. These are some tough engineering problems to solve. But by following some clear best practices, developers build these incredibly robust systems.
This means using unique keys for the really critical stuff, thinking about idempotency from day one instead of as an afterthought, choosing the right tools like put or delete when they fit, and maybe most importantly, testing relentlessly to make sure everything works, especially when things go wrong.
So yeah, idempotency is one of the most important silent heroes of system design, making sure that a simple network glitch doesn't snowball into a huge problem. It really makes you wonder, what other clever, invisible safety nets are out there, just quietly making our complex digital world a little more predictable?